If you want to understand climate change, stop looking in the air. Over 90% of the excess heat trapped by greenhouse gases does not stay in the atmosphere. It goes into the ocean. And right now, the ocean is absorbing more heat at any point in recorded history. This is the Ocean Decoded, where we break down what's really happening in the ocean and why it matters. So let's get into it. So here are the basics. About 90 to 93% of the excess heat from greenhouse gases goes into the ocean. Only about 1 to 2% remains in the atmosphere, and the rest goes into melting ice and warming land. So here's how climate change works. Essentially, you have a greenhouse gas effect. It traps long wave radiation. So you have this big globe, you have the atmosphere, all the greenhouse gases like CO2 and methane go into the atmosphere. It traps this long wave energy. It can't get out. It can't find its way out into space. So it stays in here. All that extra energy accumulates in the Earth system, and it heats it up. Water has a high heat capacity. So the ocean, which covers more than 70% of our planet, acts like a massive heat sponge. The upper 2,000 meters of the ocean have been setting consecutive heat records since 2017. In fact, in 2023 and 2024 were record-breaking years for global ocean heat content. One of the greenhouse gases, carbon dioxide, those levels now exceed 420 parts per million, ppm. It's higher than any level in at least 800,000 years. That's a lot. More greenhouse gases means more trapped energy. So the fact that we continue to pump in greenhouse gases like CO2, all that energy is trapped. We just continue to positively feed climate change, going more and more and more and hotter and hotter and hotter, and those levels increase. As those levels increase and the heat content increases, Arctic sea ice melts and it continues to decline. When you have less white surfaces like sea ice, it means that more dark ocean is exposed, and dark ocean absorbs more solar radiation. It's called the albedo effect. Essentially, when you look at anything that's white, it reflects heat, so less heat is absorbed. When it is dark, it's dark heat. It absorbs everything. A clear example is like when you wear a white t-shirt. You wear a white t-shirt so that you are cool, you're calm. It's when you go out in the sun, it's nice and clean, you're not as sweaty. You don't absorb as much sun as you would in a dark t-shirt. You wear a dark t-shirt, you absorb that sun, you get hot, and you feel it right away. Simple thing too, if you look at concrete surfaces compared to like dark asphalt, you'll get that asphalt heated up, whereas the concrete doesn't heat up as much. It's the albedo effect. It's something that affects the ice. As the sea ice melts, because the heat content in the ocean is hot, you get less reflective surfaces. The sunlight continues to get absorbed by the dark ocean, and it continues to heat up, melting more sea ice. So it's just that positive feedback loop that continues to melt sea ice, melt reflective surfaces, and you continue to get heated area. Just like as you see more forest fires happen, wildfires happen, all that carbon dioxide and methane that are trapped, all that carbon that's trapped from the trees, as they burn, it releases CO2, it releases methane, it goes into the atmosphere, greenhouse gases, continues to heat it up, and we get less surface and less trees to actually absorb them, right? And less plant life to absorb them. Mangroves, seagrasses, and kelp are really great. Algae are really great to absorb these types of carbon dioxide, these greenhouse gases, but you need more of them. But also when you have these wildfires happen, it gets even worse. Now, one thing that's interesting is recent research suggests that reductions in the sulfate aerosols, so for those aerosol cans that we used to have a lot of, aerosols in the 80s. I remember watching G.I. Joe, and you saw the cartoons that basically saying, hey, we need to fix the hole in the ozone layer, and there's all these sulfates, aerosols in the atmosphere, and it's causing this big hole in the atmosphere, in the ozone layer, and we need to stop doing that. So having less aerosols, having sulfate over the years, and even within shipping regulations, you saw reduced sulfur emissions, which may have slightly reduced the atmospheric cooling, because all those aerosols in there would actually cool the planet. But cleaner air means less sunlight reflection. So that means there's more sun that comes in. That warming signal becomes more visible. So even though we see a reduction in pollution, the air get cleaner and more sunlight going into the oceans, and it's less reflective. Of course, you have natural variability that happens, and it can get exacerbated by climate change. So El Nino events redistribute heat. Essentially, in 2023 and 2024, El Nino amplified already elevated baseline ocean temperatures. So this natural variability layered on top of long-term warming trend. That's what this is. Let's talk about where the heat is going. It's not just on the surface. Surface warming affects marine heat waves. Heat is penetrating deeper into the ocean. Deep ocean heat uptake changes circulation patterns. So let's talk about AMOC, the Atlantic Meridional Overturning Circulation. This happens in the Atlantic Ocean. You see the Gulf Stream come out of the Gulf. It goes up to the Atlantic, up the east coast of the U.S., off the coast of Canada, it kind of takes a turn, and it goes all the way up to the U.K. That circulates. So what happens is you get this warm, salty layer. It gets to the colder areas, like that dense layer, when it hits the cold, will go down as the heat evaporates into the atmosphere, causes rain and precipitation you see in like Nova Scotia and Newfoundland and so forth. And then that will come down, that cold water that's left at the top and salty, it's dense. So it sinks to the bottom and it circulates back around. And it just continues to have this conveyor belt of ocean circulation. That drives a lot of the weather systems that we know, the weather patterns that we know. But what happens is as we get hotter and hotter, that circulation pattern gets slower and slower and slower, which changes the ocean circulation as that conveyor belt gets slower. So as we see warming and that change in the speed of the Atlantic Meridional Overturning Circulation, which is AMOC stands for, you start to see change in wind patterns. You'll see change in precipitation. It gets pretty hectic. It's going to change if that circulation stops or slows down even more. Because the wind patterns are going to change, we're also going to see a change in how the ocean mixes. Actually, it's going to mix less. So we're going to see layers of stratification where water bodies aren't going to move up or down because there's no wind to actually change and break those barriers so that we get a mixing. So it's just going to kind of stay still. It's very much like when you mix oil and water. You see that layer. The dense layer will go down to the bottom. The less dense layer will stay at the top, but it won't mix until you actually shake it around. That's like wind. The wind will actually shake the ocean around and the circulation will actually mix and you'll actually get a mix. So you get less mixing. The warmer water surface becomes lighter. And so then you get less mixing. Then you get nutrients that'll stay trapped below and impacts on fisheries productivity. So all those nutrients that are below, when those come up, that actually affects, and like the fish can eat it, the larvae can eat it, all those phytoplankton and zooplankton, all that stuff that's normally gets mixed will be good for fisheries, for that productivity. And you're not going to get that if you have a stratification. So now why this matters to marine life and to us, to people, is you have marine heat waves that cause chloral bleaching events. We've seen that in the Great Barrier Reef a number of times where 90% of the Great Barrier Reef corals will actually bleach. Some will recover, many of them will recover, but every year it happens, it's going to be less likely to recover. Kelp forests will die off because of the heat. They just can't take the heat. All these plants and these algae and like seagrasses, plants and algae and kelp and corals as animals, they all have their own specific heat temperature ranges. So when those go out of whack, if those go too high, it could actually hurt the corals. It could hurt the kelp forests. It could hurt seabirds, like having starvation events because there's no fisheries productivity. And then you have mass mortality of invertebrates, whether it be corals, whether it be other invertebrates like crabs, shrimp, because there's no food productivity because the corals are dead, the seagrasses are dead, the kelp's dead, and then you're not going to have anything left. So what happens when you start to get more and more of these events, these heat waves, and you start to see the degradation of coral bleaching, less coral complexity, which I talk about in the How to Protect the Ocean podcast. If you want to go head over to Apple Podcasts or Spotify and follow that channel, you can do that as well. If you want to take it on the run and have ocean news 5 days a week, you can check that out. We talked about coral complexity last week. Fisheries shift poleward, so it gets hotter in the middle, like by the equator, and it gets hotter and hotter as we rise in latitudes. Those fish who can't take that heat move up. They want cooler waters. And so you're going to get a shift in fisheries more towards the poles, so either the north or south poles. And then species move out of their traditional ranges. We're starting to see the North Atlantic right whale start to move more north because it's warmer up there. So they can actually extend, or they're going to go up there. They're not going to go as far south because it's going to get too warm. They usually go down to Florida, and that's going to get too warm. Now, this is a critically endangered species. This is a species that we have to make sure that if it does go to a new area, that it doesn't get hit by ships or get hit by entangled fishing gear. So there are more regulations that are going to happen in these new areas. And then, of course, when you have heat and you have a lot of nutrients that are going into the water because of more pollution, you get harmful algal blooms. You get red tides. We've seen that in Florida year after year after year. It seems like every year these days that we're starting to have more and more red tide events where they're like epic red tide events. You see manatees, dolphins, sea turtles, sharks, fish, invertebrates all washed up on the beach, and it just smells like death. It's a horrible experience for anybody to see. It's traumatic to see all these animals dying, but eventually it starts to rot away the life that's in the ocean. And if you have that every year or every other year or more and more, you're going to start to see the degradation of these habitats because they just can't take it anymore. You're also going to see stronger cyclones, hurricanes. It's all fueled by warm water. We saw that happen over the last few years. As the water is warming off the coast of Florida and in the Caribbean, we're starting to see more intense and rapidly intensifying hurricanes that's causing more and more damage to island communities as well as coastal communities in the U.S. When we look at human implications of these massive heat waves, we're looking at a problem with food security, problem with coastal economies getting hit by storms and more intensified storms. Insurance companies are moving out of areas where there could be wildfires, where there could be sea level rise, increased sea level rise. They're not covering these homes anymore. So that means those homes, once they're lost, they're lost. Nobody can get coverage on them. Now you can build up around it and you can fortify it and you can adapt to it. But eventually, it's predicted that half of Florida is going to be underwater at some point in the not too distant future. That's not a good thing for all of these people who have homes there, have their lives there, that are going to be uprooted because water's going to take over. It's already happening in the groundwater, in the ground. We're already starting to see in certain storm events, the water, because there's nowhere for it to go, it's still just in the soil and it starts to rise. Instead of storm water coming in from the coast, it's just rising as it gets absorbed throughout the land. So, of course, you're looking at insurance markets that are leaving, disaster risk that's happening even more with intensified storms. There's a lot of stuff that's happening. The ocean has been protecting us by absorbing this heat over the number, decades and centuries. But protection comes with consequences. It comes with consequences. If the ocean were not absorbing this heat, though, atmospheric temperatures would be far higher. The ocean is actually slowing down atmospheric warming, but the stored heat does not disappear. It actually drives sea level rise with thermal expansion. As it gets hotter, the water expands. We get stronger storms, as I mentioned earlier, and persistent marine ecosystem disruption. That means ecosystems are being disrupted at every part of this climate change. Every time water warms the ocean and it falls out of the ranges of coral reefs, seagrasses, mangroves, salt marshes, mud flats, whatever that might be, it disrupts everything. It disrupts the processes, it disrupts the chemicals. We're seeing ocean acidification happen more and more, which means that oysters, mussels, clams, scallops, and we're seeing a lot of other things and corals, they're just not forming as much. And that could be a huge problem. So thermal expansion accounts for a significant portion of the observed sea level rise. Just think about that. As the ocean warms and as the ocean continues to expand, we're starting to see more and more sea level rise, where some communities in the South Pacific and other areas have actually had to move because of sea level rise. Their homes are just gone. They're just flooded constantly. Now, what does this mean going forward? Ocean heat content is one of the clearest indicators of climate change. The more we heat its stores, the worse off we are. It is less noisy than air temperature. It's a clear indicator of climate change. We can watch it increase slowly. It tells us how much energy imbalances exist in the Earth's system. So future trajectory depends on emissions. If emissions stabilize, ocean heat uptake eventually slows down. If emissions continue rising, ocean heat records continue to break. The ocean is not overheating randomly. It is responding exactly as physics predicts. So that's the episode for today. I hope you learned something from this episode about ocean warming and how dangerous it can be, but how we can really stop it, even though it might take a little bit more time because it'll just take a little bit more time to rebound. But it does help. And so reducing emissions will help us in the future. And I hope this episode's helped you out. And if you have any questions or comments, please let me know in the comments below. And if you want to understand what's really happening in the ocean, not just the headlines, subscribe to Ocean Decoded. Next episode, we break down marine heat waves and why they are becoming the new normal. Thank you very much for watching. I'm your host, Andrew Lewin. Have a great day. We'll talk to you next time, and happy conservation.